Hello and welcome. I am your host and speaker Aditi, and I'm Associate Data Engineer at Infometry. Thank you for taking the time to join us today. In today's webinar, I'll be talking about SQL for beginners. Feel free to drop questions on the topic or share your struggles and experiences during this live session. We will answer your queries through chat. Let's start the session. This session is organized by Infometry. We are a pure play data analytics company based out of Fremont, California, with our offshore development center in Bangalore, India. We came into inception back in 2010, and since then, we have been offering domain-specific analytics solution for high-tech, energy, life sciences, retail, manufacturing, and finance customers. Being a data analytics software services and solutions provider, we focus on delivering predictive and prescriptive analysis solutions, cloud data warehouse implementation, data governance, enterprise service bus, microservices-based integration solutions, big data, cloud DevOps, Salesforce CRM, and product engineering. Infometry has been an engineering and consulting services partner for companies like Informatica, Matillion, Snowflake, Tableau, Adaptive Insights, Looker, etc. Infometry offers domain-specific analytics solution for high-tech, energy, life sciences, retail, manufacturing, and finance customers. In addition to the services, we have also developed more than 15 cloud connectors for IICS. One mentioned under Blue Blocks are developed and owned by us, and the rest are all developed by us only for organizations like Informatica, SAP Caritas, etc. We have developed state-of-the-art analytics solution InfoFiscus, which can be hooked to any on-prem or cloud CRM or ERP or planning apps. InfoFiscus is 100% cloud-based pre-built analytics software developed using open architecture. InfoFiscus comes in 3 different flavors: finance, supply chain, and sales and marketing analytics. We are delighted to announce the launch of the next generation InfoFiscus Sales Analytics Snowflake native application, which aims to streamline sales analytics for customers using Salesforce, Marketo, and Snowflake. That's a quick introduction, and now let's move to our today's agenda. SQL for beginners, mastering the fundamentals. SQL stands for Structured Query Language. SQL is used to manage data and organize tables within relational databases. Tables. Tables organize data into rows and columns. Relationships. Tables can be linked by relationships, enabling efficient data retrieval and analysis. SQL is a standard programming language used to manage and manipulate relational databases. It enables users to perform tasks such as querying data, updating records, inserting new data, and deleting records. SQL is essential for interacting with database management systems like MySQL, PostgreSQL, Microsoft SQL Server, and Oracle. Key features of SQL include data querying. Data querying uses commands like select to retrieve data from one or more tables. Data manipulation. Data manipulation commands like insert, update, and delete modify data in tables. Data definition. Commands like create, alter, and drop define the structure of the database. Data control. SQL provides permission through commands like grant and revoke. SQL is widely used in data engineering, data analysis, and application development due to its powerful, efficient handling of relational databases. DDL. DDL stands for Data Definition Language. DDL commands are used to define and modify the structure of a database. They allow you to create, alter, and drop database objects, including tables, columns, and constraints. DDL commands are create, drop, alter, and rename. Create. Create statement is used to generate new database objects like tables, index, view, or databases. It defines the structure, specifying attributes such as columns and data types when creating a table. The command is essential for establishing the foundational elements of a database, allowing you to step up schemas that organize data. You can also create other database objects like procedures and triggers. Once executed, the object persists in the database unless explicitly removed. Drop. The drop statement is used to delete an existing database object such as table, index, or view from the database. When executed, all the data within the object and its associated schema are permanently removed. The action is irreversible, meaning there is no way to retrieve the dropped object until backups are in place. It is used when an object is no longer needed. Be cautious when using drop as it can affect other database objects if they are dependent on the object being removed. Alter. The alter command allows modifications to existing database objects like tables or columns. It can be used to change the structure of a table by adding, deleting, or altering columns and constraints. The alter statement is critical when a table or object needs to adapt to changing requirements. It ensures the schema can evolve without requiring the deletion and recreation of objects. It is widely used in database maintenance to improve performance, storage, or usability. Rename. Rename is a command used to change the name of a database object, such as a table or column, without altering its data structure. This is typically done for clarity, consistency, or alignment with new naming conventions. It can also be useful when a mistake has been made in naming during object creation. The command allows for seamless name transition without needing to drop or recreate the object. It ensures that the references to the object remain functional after the name change. If you are a Snowflake user, then I suggest do try our InfoFiscus DDL automation. It is exclusively designed for Snowflake database generation, allowing users to save valuable time and minimize the risk of errors when creating, modifying, or managing database schema objects. With a click of a button, it can generate DDLs. Data analysts and business analysts can use this tool before involving database engineers and ETL developers, making it an indispensable asset for any organization that manages databases. Creating 100 tables simultaneously takes just a few seconds. It offers the capability to back up changes to the database schema, allowing for easier tracking and auditing of changes over time. It is designed to consume significantly less space. The InfoFiscus DDL automation tool is user-friendly, even for individuals with limited technical expertise. DML. DML stands for Data Manipulation Language. DML commands are used for manipulating data within existing tables. They allow you to insert, update, and delete data records. DML commands are insert, update, delete, and select. Insert. The insert command is used to add new records into a table. It allows you to specify the data for one or more columns in the table. This operation affects only the rows you explicitly specify and ensures that the values conform to the table schema and constraints. If any constraints are violated, such as unique or foreign key restriction, the insert operation will fail. It's essential command for populating databases with initial or incremental data. Update. The update command is used to modify existing records in a table. It allows you to change the value of one or more columns for rows that meet certain conditions. Unlike insert, update works on rows that already exist and can target a specific subset of rows through a where clause. If no condition is provided, all rows in the table may be updated. Like other DML commands, it is subject to constraints like foreign keys and unique indexes, which may prevent certain updates. Delete. The delete command is used to remove records from a table. It can be applied to specific rows by specifying a condition in the where clause, and if no condition is provided, it will remove all rows from the table. However, the structure of the table remains intact. Delete commands can also trigger referential actions like cascading deletes in relational databases if foreign key constraints exist. Proper care should be taken when using this command, especially without conditions, as it can result in the loss of critical data. Select. The select command is used to retrieve data from one or more tables in a database. It allows you to specify which columns to retrieve, and through use of various clauses like where, group by, and order by, it provides control over filtering, grouping, and ordering the results. Select is highly flexible, supporting complex queries involving joins, subqueries, and aggregation. It forms the foundation of reading data in SQL-based system and can return 0 or more rows based on the conditions provided. Fundamental SQL query select. Select specifies the columns you want to retrieve from the table. The select statement in SQL is used to specify the column that you want to retrieve from a database table. It allows you to choose specific fields or expression that should be included in the result set. By default, if you use select star, it retrieves all columns from the specified table. The select clause can also include aggregate functions, calculations, and even aliases to rename columns in the output. This flexibility makes it a powerful tool for extracting relevant information from large data sets based on the user's needs. From. From indicates the table or tables from which data should be retrieved. The from clause in SQL indicates the table or tables from which to retrieve the data. It is essential because it tells the database where to look for the specified column listed in the select statement. You can also join multiple tables using various types of join in the from clause, enabling the retrieval of related data from different sources. This is particularly useful in relational databases where data is normalized across multiple tables. The from clause can also include subqueries that provide temporary tables for the outer query. Where? Where filters select rows based on column condition. The where clause is used to filter records written by the select statement based on the specified condition. It allows users to define criteria that the data must meet to be included in the result set, which is crucial for narrowing down large volumes of data to only what's relevant. Conditions can include comparisons, logical operators, and even functions to define filtering process. Using where helps improve performance by reducing the amount of data processed and written, making queries more efficient. Order by. Order by sorts data by columns in ascending or descending order. The order by clause in SQL is employed to sort the result set of a query based on one or more columns. It allows user to define the sort order, which can be either ascending or descending, ensuring that the retrieved data is presented in a meaningful way. By default, sorting is done in ascending order if no specific directive is provided. The order by clause can also handle multiple columns, which is beneficial when sorting by secondary criteria. This sorting capability is essential for data analysis, reporting, and user interface design, enhancing the overall readability and organization of query results. Join. Join combine data from multiple tables based on common columns, giving a complete view. SQL join has 6 types of joins: inner join, left join, right join, full join, Cartesian join, and self join. Inner join. An inner join is used to select only the rows that have matching values in both tables involved in the join condition. This means that for a row to appear in the result set, there must be at least one match between the values of the columns specified in both tables. Any rows that do not have matching values in either tables are excluded from the result. Left join, also known as left outer join. A left join returns all rows from the left table and matched rows from the right table. If there are no matches in the right table, it returns null for those columns from the right table. This is particularly useful when you want to retrieve all records from the left table regardless of whether they have a match in the right table. Right join, also known as right outer join. A right join works similarly to a left join, but instead of returning all rows from the left table, it returns all rows from the right table and the matching rows from the left table. If no match exists in the left table, it fills the missing columns with null. For instance, if you wanted to see all orders in the corresponding customers, but you also wanted to include orders that were placed without customer information, you would use a right join. Full join, also known as full outer join. A full join returns all rows from the tables with matching rows where available. If there is no match between the two tables, the result will include null for missing data from either table. It's useful when you want a complete set of data showing all rows from both tables, regardless of whether there is a match. Self-join. Self-join is a joint table with itself. It is useful when you want to compare rows within the same table. To perform a self-join, you typically use table aliases to differentiate the instances of the table. Nested statement. Nested statement allow you to embed one query within another, enabling more complex data retrieval and manipulation. They can be used to filter data, aggregate results, or perform conditional logic. Functions. SQL functions provide predefined operations that simplify data manipulation and analysis. They can perform a wide range of tasks, including calculation, string manipulation, data operations, and more. Commonly used functions are string functions, numeric functions, datetime functions, and null functions. String functions. String functions in SQL are designed to manipulate and process string data types. These functions allow users to perform operations such as concatenation, substring extraction, and case conversion. They are essential for tasks like formatting text, searching for specific patterns within strings, or transforming string data for consistent output. Common string functions include operations like trimming whitespace, converting strings to upper or lower case, and replacing characters within a string. Overall, string functions enhance the ability to handle textual data efficiently within SQL queries. Numeric functions. Numeric functions in SQL are utilized to perform mathematical operation on numeric data types. These functions can carry out calculations such as addition, subtraction, multiplication, and division, as well as more complex statistical operation like averages, minimums, and maximums. They are particularly useful for data analysis and reporting, enabling users to derive meaningful insights from numerical datasets. Numeric function can also include rounding numbers, extracting integer parts, or calculating the absolute value. By leveraging these functions, users can manipulate and analyze numerical data effectively. Date and time functions. Date and time function in SQL are used to manage and manipulate date and time values. They allow users to perform operations such as extracting specific components from a date, calculating intervals between dates, or formatting date and time output in various ways. These functions are crucial for applications that require time-sensitive data processing, such as scheduling, reporting, and time series analysis. Additionally, date and time function can handle various time zones and provide conversion between different formats. They help ensure that temporal data is managed accurately and efficiently in SQL queries. Null functions. Null functions in SQL are specifically designed to handle null values, which represent the absence of a value in a database. These functions allow users to identify, replace, or manipulate null entries in the datasets. For instance, users can check for null values, substitute them with default values, or count the number of null entries in a column. Null functions are essential for maintaining data integrity and ensuring that queries return meaningful results, especially in data sets where missing values are common. By effectively managing null values, SQL users can improve the accuracy and reliability of their data analysis. Thank you all for joining today's webinar. I hope you found the information valuable and insightful. Before we wrap up, I'd like to open the floor for any questions you may have. Feel free to ask about the topics we discussed or any related matters you're curious about.
Hi Aditi,
Hi, Sandhya.
myself Sandhya. So, what are the key advantages of organizing data into tables in relational database?
Relational databases organize data into tables with rows and columns, providing a structured and efficient way to store, retrieve, and manage information. This structure supports relationship between tables and enabling complex data analysis and minimizing redundancy.
Yeah, hi Aditi, Kokila here.
Hi, Kokila.
Yeah, can you explain how Infofiscus automates DDL process for Snowflake?
Yeah. Actually, Infofiscus automates schema creation, modification, and management in Snowflake. It reduces manual efforts and ensures consistency. It provides pre-data build data pipelines and supports multiple environments for seamless database deployment and also helps in analytics.
Okay, thank you.
Yeah, thank you.
Hey, hi Aditi. This is Priyanshu.
Hi, Priyanshu.
So, my question is, what is the difference between DML and DDL commands in SQL?
So DDL, it stands for Data Definition Language, and DML stands for Data Manipulation Language. DDL defines and modifies database structures such as creating or altering tables, while DML operates on data within structures such as inserting or updating records. And DDL sets up the framework, whereas DML works with the data inside the framework.
Okay, thanks.
Thank you.
Yeah, hi Aditi.
Hi.
Thank you so much for amazing webinar on SQL. I hope everyone found it really insightful. And for the future webinars, make sure that you follow us on our website and social media. Yeah, thank you so much for this webinar. Have a good day, everyone.
Thank you, Dheeraj.